Okay, so here's a practice free response question. So, a researcher conducted a study to investigate whether local car dealers tend to charge women more than men for the same model of car. Using the information from the county's tax collector's records, the researcher randomly selected one man and one woman among everyone who had purchased the same model of an identically equipped car from the same dealer. The process was repeated for a total of 8 randomly selected car models. The purchase prices, man minus women, or women minus man, are shown in the table below. Summary statistics are also shown. Does the data provide convincing evidence that on average, women pay more than men for the same model of car? Okay, so couple things. One, we have to identify what type of scenario this is, okay? Now, they're trying to give you a little bit of a head fake here. All right. They're giving you two different samples. They're saying here's women, here's men. Okay. So at first glance, you would say, okay, this is a two sample t test, but it's not. If you look, each car model, all right, is in both sample men and women, and then they give you a difference. Okay. So because in the entire sample of women and the entire sample of men, observations are paired up. All right. The same car model is in both women and men. This is actually a matched pair scenario. So we are going to use a matched pair scenario. All right. So our null hypothesis is going to be, so they want to see that women pay more than men. All right. So the assumption is that they pay the same. So we're going to say the null is that the mean of the differences is 0. All right, women paying more than men would give a positive value. So our mean of differences is greater than 0 is the alternate hypothesis. And then we're going to put this into context, okay? So the average difference in car price women minus men, is greater than 0. So there is the P and H in phantoms, okay? We have our parameter of interest is spelled out in the alternate hypothesis, and we have our hypothesis statement, okay? Let's use this page to really quickly do the assumptions and conditions. Okay, number 1, random. So let's look through the question. Where does it say anything about random, okay? We have 8 randomly selected car models, all right? We also have randomly selected one man and one woman, okay? So we're going to say randomly selected cars, man and woman. All right, so randomization is good to go. For an independent sample, okay, so we have 8. So we're going to do 10 times 8 is 80. So assume more than 80 car models. Okay, as for normality, and once again, this is where they're trying to head fake you. They are giving you a dot plot for the women, which this is obviously skewed to the right. They give you a dot plot for the men, which is also skewed to the right. However, though, in a matched pair scenario, that means absolutely nothing. We want to look at the differences. And if we look at this differences down here, all right, this looks pretty good. This is symmetrical. There's no obvious skewness or outliers in the dot plot. So we are good to go for normality. So independence is a check. So we are good to go. We've met our conditions, and we are going to move on with our matched pairs t-test. Okay, so in a matched pairs t-test, let's go ahead and get our test statistic. We're going to do the average of the differences minus the mean of the differences divided by standard deviation of the differences divided by square root number of differences. Okay, so our average is going to be 585 minus the null hypothesis is going to be 0. Actually, this is incorrect notation right here because this average came out of the sample. So we're going to change that really quickly. Standard deviation of the differences is 530.71 divided by our sample size is 8. Okay. Once again, that can be really ugly to try to run through the calculator. So we are just going to use our little calculator here. This runs at this point the exact same as a one sample t-test. So you go to t-test, enter. We have statistics. We don't, and I mean, you could go back. It gave you the individual data points, but we don't need to. We have stats. All right. So our population average we're checking against is 0. All right. Our sample is 585. Our standard deviation is 530.71. Our sample size is 8, and we are checking for greater than 0. Run it, and we get a t-score of 3.12 and a p-value of 0.008. Also, remember, whenever using a t-distribution, always indicate what your degrees of freedom are. So in this case, our degrees of freedom are 7. It's just the sample size minus 1. So really fast, here's what just happened. So we're going to call this the differences, okay? We're assuming that the mean of the differences is 0. When we ran our numbers, we got 585 is what we got for the mean of our differences, okay? So if I make a second axis for t-scores, 0, 585 gives us a t-score of 3.12, and our p-value was 0.008. That means that this area right here is 0.008, okay? This area right here. This area is so far away from the middle that this area is 0.008. It is less than 5%. Therefore, we are going to reject the null hypothesis. Remember, the further away from the mean we are, from the expected value, the smaller the p-value is going to get. If the p-value gets as small as our level of significance, which in this case is 0.05, we reject the null hypothesis, okay? And this is where you wrap it up with your conclusion statement, okay? Based on our t-score of 3.12, we reject the null hypothesis. If men and women paid the same for each model car, or for each car, on average, the probability of getting these results or more extreme is 0.008, which is less than our alpha of 0.05. So remember, second sentence, that puts our p-value into context, and then finally, we make our statement. There is evidence that women pay more on average for cars than men. All right, once again, just double check your phantoms, okay? Just to make sure that you have every little component that you need. P is your parameter of interest. We have that in the null or in the alternate hypothesis. H is for a hypothesis statement. We have it. A is for assumptions and conditions. Boom, we have that down here. N is for name the test. We've named the test twice, actually. We gave both the actual name of it, match pairs t-test, and we wrote the general formula. So we met that criteria twice. T is test statistic, 3.12. O is for obtained p-value, that's 0.008. M is make a decision. We decided to reject the null hypothesis. And then S is summarizing, where we have a summarization that includes interpreting the p-value.